And to kind of continue this trend, I think we're really doubling down on being able to focus on interesting and important problems. So without further ado, I'd like to invite Vitalik on stage to talk about ideas for things worth building.
Okay, hello everyone. Okay, so how are you today? Wait, what? Okay. Okay. Aw. Okay, so great. Thank you. So today, what I wanted to talk about is a bit of kind of the intersection between some of the things that are happening in the Ethereum space on a from a very technological point of view. So there's a lot of exciting things happening in Ethereum technology with scaling, privacy, a lot of other different topics, and just some ideas for what can happen on the what kinds of things I think might make sense to start building on the application layer. Now, we sometimes think of technology and applications as being separate, but I think it's actually very important to think about them together because improvements to technology can make new kinds of applications possible, right? They can make applications possible by making them cheaper. Sometimes they can make applications possible by creating new tools, by making it safer to use the Ethereum blockchain, which can make applications more accessible. And so what are we going to see from our technology in the next few years, and what does this mean for what kinds of things it makes sense for people to really start building today? So I feel like we've, at least on the internet and on the Reddit and the Twitter and the Bankless and the ETHGlobal and all of these lovely forums, talked about the merge a lot. So I'm not going to talk about the merge. But I mean, it will happen. Apparently, it might even happen on Mexican Independence Day, which is yeah, but so switch to proof of stake, great. What comes after the switch to proof of stake, right? So probably the biggest thing aside from the switch to proof of stake that Ethereum developers are focusing on today and really have been focusing on for a long time is scalability, right? So who remembers last year when it cost $5 to send a transaction? Who enjoyed paying $5 to send a transaction? One person did, I did not, right? So this is a problem, right? There's not enough space in the Ethereum blockchain today for all of the applications that people want to make, and this means that Ethereum is too expensive for people, and this is a problem, and we have to fix the problem, right? So now, if you look at the charts, then, sure, today, sending a transaction is maybe a few times cheaper than it was last year because last year was a bull market, and now the bull market is kind of not a bull market right now. But markets are random, right? They can go in random directions, and so we don't want to kind of rely on markets being in one place or another place for transactions to be cheap. We want transactions to just always be cheap, right? And the only way to make transactions reliably cheap in the long term is to increase the amount of space on the chain, right? Increase the amount of space that transactions can use. Now, in 2020, I published this document called the rollup-centric roadmap, and at the time, I think the Ethereum ecosystem was really starting to move in that direction already, right? And the basic idea is to split up the Ethereum ecosystem into layer 1 and layer 2, where the job of layer 1 is to be decentralized, to be safe, to be open, to be censorship resistant, to be permissionless, and to really focus on providing these things and to become more stable and even try to become simpler over time. And it's the job of layer 2 protocols to add scalability on top, right? And that was 2 years ago. And 2 years ago, like rollups were mostly test networks and ideas. But fast forward to today, and today there's a lot of scalability projects that are live now, right? So Polygon is sponsoring this. And I mean, Polygon in its current form, right, it is a sidechain, and so you do have to trust it. But Polygon is also, they've been doing all of this excellent work on adding zero knowledge proofs, and so they are going to also have a ZK rollup, which is really amazing, right? Now, also Arbitrum continuing to move forward, lots of great work. Optimism, I hear people from the Optimism team might even be here. So, StarkNet, zkSync, just all of these projects that are just so much more mature than they were 2 years ago. Now, this scaling through roadmaps is something that has started and it's going to continue, right? So over here I have these two charts. This is so the first chart is roll-up data space per block, right? So this is how much space there is and there is going to be in the Ethereum blockchain for for rollups to use to put transaction data. So today the amount is fairly low. It's basically rollups have to compete with all of the other Ethereum applications for space. And so today, I think the amount of rollup data on chain is like maybe somewhere between 10 and 50 kilobytes, maybe a few days more, maybe some days less. I don't know the exact number, but like it's not far from that. After the merge, the next big focus of the client teams is likely to be what we call proto-dank sharding, which is also called EIP 4844. And this just adds a much larger amount of space for projects to, or a much larger amount of data on chain that rollups can use to store transactions. And after proto-dank sharding, we go up to full dank sharding, right? That's a typo. This is 1 megabyte. This should be 16 megabytes, right? So a huge amount of space going up by a lot. Now, in the meantime, also some work happening kind of more quietly, but still important, which is reducing the amount of space required for every transaction on a rollup, right? So this is just some data for an ERC20 transfer. So an ERC20 transfer on a rollup today, 180 bytes. A few months ago, Optimism added like this basic form of compression that we call 0-byte compression, knocks it down to about 150. Signature aggregation, you can knock it down to 128. You need ERC4337 for that. Better compression, 75, and like totally amazing compression, 23, right? So on top of all of this extra space, the amount of space that every transaction needs is slowly kind of in the process of becoming and is going to become 9 times cheaper. So the conclusion of kind of all of these things put together, right, is that I think we have a lot of good reasons to believe that the Ethereum blockchain will be like much cheaper, like more than 100 times cheaper. Like it will be building and doing things will be more than 100 times, maybe even 1,000 times cheaper than it was last year. So the question for people building applications, right, is I think there's two questions. One question is, how can you help the transition? And the second question is, if things are going to be 100 or 1,000 times cheaper, what will you be able to build that you cannot build today, right? So in some of the presentations at the hackathon, I already saw, I think people are already having like exactly the right kind of thoughts in that direction, right? So for example, a lot of applications focusing on like point of sale and in-person payments. And in-person payments are actually something like, they're probably, or just payments in general, right? They're the earliest application of a blockchain, right? So who here read the Bitcoin white paper? Who here remembers the title of the Bitcoin white paper? Bitcoin, a peer-to-peer electronic cash system, right? Electronic cash, use it to pay people for stuff. Now, this is something that like earlier on, I think a lot of people really believed and a lot of people really tried hard to do, right? So like there's like these big efforts to try to convince a lot of like stores and restaurants in one particular place to all accept Bitcoin. There were projects trying to like convince a lot of online merchants to accept Bitcoin. And with Ethereum, I think this kind of continued at the beginning, but then sometime like over the next few years, transaction fees just became way too high, and I feel like the ecosystem kind of quietly mostly gave up on that, right? And I think in fairness, that kind of makes sense, right? Because if you remember in 2013, one of the biggest arguments that people used for why like you as someone in a store or like online store or physical store should accept Bitcoin is the fees, right? PayPal charges 29 cents plus 2.9% and even more if it's international. Credit cards charge even more. And here's cryptocurrency Bitcoin 1 cent transaction fees, right? So it worked in 2013, but then in 2017, instead of the transaction fee being 1 cent, it was $50. And so it did not work anymore, right? But with scaling, like we are looking at transaction fees going back down to 1 cent and, maybe even lower. So maybe it actually, and, today we're not in 2013. Today we're in 2022, and the size of the Ethereum community, the size of the crypto space. Also, Bitcoin people doing, I think, some similar work with the Lightning Network as well. The size of the space, the amount of developers that are there that can actually like build really good and user-friendly solutions. There's just so much more, right? So I think it actually makes sense to try to do in-person payments and online payments again. So that's just one example, right? But the question that you should ask is like, what other applications are not possible today or are not possible in 2021, but they are possible in a world where transactions are 100 times cheaper? So that's one thing that we can build, that as a developer you can look at, right? The other thing you can look at as a developer is how might you participate in this transition, right? So in here, if you look at the chart closely, like there's a couple of these very specific technologies that I mentioned, right? So ERC-4337, I'll talk about it a bit later, but it's basic account abstraction. It's this kind of standard on top of Ethereum that gives wallet designers a lot more freedom to choose, like basically how wallets do their authentication. So you don't have to have one key, you can have multiple keys, you can have different signature algorithms, you can have recovery, you can do a lot of things. And one of the nice things that you can do with it is a signature aggregation, right? So you can take a large number of signatures, combine them into one signature, and you just save a huge amount of data, right? So this is something that can like make a big difference, but it's something that people have to actually do. It's something that people have to implement wallets for. There are already a couple of teams trying to build wallets that support ERC-4337, but you can build more, right? And you can join those teams, and you can build your own. It's I think an area where there's still a lot more room for people to participate. Better compression for rollups, right? So like, what's the difference between like where we are now, 154 bytes, and going down to 75 and even going down to 23? Like if you're part of a rollup team or you want to contribute to a rollup, this is one of those things that actually could be very valuable to contribute. Software for nodes in a world that has some of these scalability upgrades. Right, so when the Ethereum blockchain has a lot more data, when it becomes more scalable, users are going to need to have like better software for being able to access and process all of this data. And this will not be something that the blockchain, the Ethereum node, will be able to do by itself, right? So like this extra software has to be built, and there are a lot of good projects that are building it, but this is also a place where there could be more, right? So this is the first category of, I think, how to think about what you can build, right? The scaling transition is happening and will continue to happen. How can you help the transition? And once we have the transition, what kinds of things that you cannot build today will you be able to build a couple of years in the future? Those are the things that it makes sense to start building today. Zero knowledge proofs. So zero-knowledge proofs are this very powerful technology that has become very big in the Ethereum ecosystem over the last 5 years. Right? Basically, it's a way to cryptographically prove that like some statement about some piece of data is correct without revealing the information about like why that statement is true. So you can say, like, for example, that I have an Ethereum address, and that Ethereum address has a valid proof of humanity profile, but you don't have to reveal which proof of humanity profile you have, right? So you can kind of like, you can have applications that increase security by kind of adding these guarantees into the application, but at the same time preserve privacy. Now, privacy is actually only one use case of ZK snarks, right? The other use case of ZK snarks that somehow the exact same technology gives us is scalability. And for scalability, ZK snarks are already being used in ZK rollups today, right? So Polygon, Polygon Hermes, ZK rollup. Yay. Come on, clap for the sponsor. They're here. Okay. Right now, they're not the only one, right? So ZK Sync doing amazing work, Scroll doing amazing work, the Ethereum Foundations team with Barry Whitehead also doing amazing work, Starknet with Cairo also doing amazing work. But so a lot of work that's happening on ZK for scalability and ZK for privacy. Now, from the point of view of an application developer, right? So my perspective on this is that the ZK for snarks for scalability stuff, that's like mostly protocol level and mostly infrastructure level, right? So it will happen in ZK rollups, and you don't actually need to worry too much about it, but it just will make everything that you do more secure and cheaper. ZK snarks for privacy are a bit different, right? Because like as an application designer, you have to think about your application's privacy situation, right? The privacy needs of every application are different, and there isn't like a way to magically provide privacy for everything, right? Like there's some pretty like fundamental technical reasons why you can't. So like basically, you can't hide all the data from everyone, because in order to make a transaction with the data, you have to have the data, right? That's like the easiest way to think about it. And so for every application, you have this question of like, well, who is going to have the data, and how are you going to use these proofs, and like who has the right to make what changes to the data? You know, how are you encrypting things? How are you hashing things, and all of this? Now, some interesting examples of this. Privacy preserving proof of humanity is like a very simple one, right? It's like if you want to create an application, like one very simple example of this might be that, like, let's say you want people to be able to like sign, like you want to be, you have some conference, and you want people to be able to like sign up and buy tickets for to that conference, but you want to limit your ticket purchases to one per person, right? So, but at the same time, you also don't want to like reveal everyone's information publicly on chain. How do you do all of those things at the same time? Well, you can make a zero-knowledge proof that says, in order to buy a ticket, you have to provide a proof, and that proof proves that you have a proof of humanity profile, and at the same time, it reveals this kind of extra secret called a nullifier, and if you make two proofs with the same profile, they're going to have the same nullifier, right? And so if you just, the nullifier by itself does not reveal anything, but it still stops you from using the same profile more than once. So this is something, I mean, I actually have a post on my blog. I wrote this a couple of months about like some very specific ways about how you use this technology, but it is powerful, right? And if you're building an application, you probably do have privacy needs, and it's important to think about those privacy needs, and ZK snarks are just a very powerful technology for dealing with privacy issues. Sometimes there are privacy solutions that are kind of simpler, and you don't need ZK snarks. So One thing that I mentioned publicly about a week ago is stealth addresses, right? So if you want to send someone an NFT and they have a public address, like you don't have to send it to their public address directly. You can generate a stealth address and you can generate an address that they control, but nobody aside from them knows that they control that address. And so like it's a little bit more low tech, but it's also another way to like just not leak a little bit less information out to the public so everyone can see. So privacy. Another really important category of applications is the Ethereum identity ecosystem. And this is actually one of my answers to the question of like, what can you build when Ethereum is cheaper that you cannot build when Ethereum is expensive, right? So I think like I've become convinced that like aside from money and financial applications, things to do with identity are probably the second biggest like category of applications on Ethereum, right? And I think the reason for this is pretty clear, right? Because Ethereum and like blockchains by themselves, in order to interact with them at all, you need to already have an identity, right? So who here has an Ethereum wallet? Okay, who here has a PGP key? See, not that many people, right? So this is like one of these kind of double-edged swords of blockchains and crypto, right? So back in the 1990s, there were like a lot of people that had these like very idealistic ideas, right? That we have encryption now and we can protect privacy and we can communicate with each other and we don't need to have corporations and governments to like snoop on everything. Now, so and then they created all of this like amazing software and everyone could generate their own key. Anyone could send messages encrypted to other people's keys, but it just never really went very far, right? Like this is a group of developers, but if I asked this at a non-technical Ethereum conference, I feel, there would still be a lot of people raising hands for an Ethereum wallet, but probably almost no one raising their hands for a PGP key, right? Why? Well, PGP keys, they're like a very difficult network effect to start, right? You have one application and no one else is using the application, and so you're only really going to use it if your friends are using it already, and it's just very difficult to get off the ground. Now, you could of course argue like, hey, we believe in freedom, we believe in privacy, we believe in like these wonderful ideologies, and like try to kind of convince people that way, but it didn't go very far. Now, instead, we have blockchains, right? And with blockchains, we have money and we have incentives and we have, people wanting to trade like $3 million monkeys. And, these. Now, there are big downsides to these, but like one of the upsides is that people definitely have incentives, right? And so it did create this incentive for even like very normal people, like just people who are not interested, like, aren't kind of like very deeply involved, like interested in kind of ideology and like freedom and privacy, like just more regular people that just wants to save money, not lose their money to hyperinflation, be able to send money internationally, just like do very simple things, and or just to like do these things, you have to create a wallet, and once you have that wallet, you can use that wallet for so many other things, right? So one of my dreams here is that we can kind of use this as a path to improving how identity works on the internet in general, right? So, like, one of the problems with identity on the internet as it exists today is that it's like very centralized, right? Like you sign in with Google, sign in with Facebook, and sign in with Twitter, and you just have like one company that controls your account. They see everything that you do. They can control everything that you do. Now, and you don't actually get that much in exchange, right? So like one argument that people sometimes make is that like, oh, it's good that that a company controls your account because, well, if you accidentally screw up, you accidentally lose your key, you can call customer service and the company will help you get your accounts back. This is actually often not true, right? Like in reality, like I've talked to lots of people who have lost their accounts, and it's actually very hard to get your accounts back. So what if instead we could use Ethereum accounts, and we can use Ethereum accounts to log into services, and even log into centralized Web2 services. So instead of sign in with Google, we have sign in with Ethereum. So this is something that the Ethereum Foundation actually started pushing kind of pretty hard last year. It gave a grants to Spruce, and a lot of other people in the Ethereum ecosystem are really kind of pushing on this. And there's more and more applications that are starting to just let you sign in with an Ethereum account. And especially if you want to target people, the Ethereum ecosystem and the crypto community, it's very convenient. Now, how do you recover your accounts, right? Let's say you have an Ethereum account and either your account gets stolen or you lose your account. Today, we're not very good at this, right? Now, there are backups and there are seed phrases and all of these things, but what happens if your account gets stolen, right? It doesn't really help. And sometimes, people are careless with their backups. Sometimes, really bad things still happen. Sometimes people are lazy. So one of the ideas that I've been a big fan of for a long time is this idea of social recovery wallets, right? Basically, the idea is that you as a user would choose some number of recovery contacts. This could be institutions, it could be family, it could be friends. You choose who they are. It could even be other wallets that you control. And if you choose some number of them, then let's say, for example, you choose 7 recovery contacts. You might need 4 of them, or you might want 5 of them to be able to recover your account if you lose your account, right? Now, it's actually, you can even make it privacy preserving. You can make it so that you don't reveal to the chain who your recovery contacts are. And your recovery contacts don't even have to know who each other are, right? So it's actually pretty strong against collusion. So this could be done, and it could work quite well. But in order to do this, you have to have an account that is a smart contract wallet, right? So you can't use a regular account, you have to use a smart contract wallet. Now, how can we make it easy to use a smart contract wallet to access your funds? Well, ERC-4337, right? This is a kind of protocol that sits on top of Ethereum that's designed to make it really easy to do this. So what do we have now, right? You have an Ethereum account, which is an account, and that is like an identity. If you want to recover your account, you can make it be a smart contract wallet. If you want to use your account, you can sign in with it. Now, if you have, generally in the centralized world, you have a username, right? And in Ethereum, we have a username, we have ENS. You can prove things about your account, right? So you can prove that, if you want to prove that you are some actual real account and that you're not a spammer, there's a lot of things that you can prove. You can prove that your account just sent at least 1 transaction on Ethereum. You can prove that you have some proof of humanity profile. You can prove that you have a pope. You can prove that you have some minimum balance. You can prove that you participated in some event. You can even zero knowledge prove all of these things, right? So between all of these different applications together, I actually think that we have a pretty powerful identity layer already on Ethereum. And all that we really need to do is just build better versions of all of these different pieces on the stack and start getting them to talk to each other more and really start connecting things together much more. And this is also something that I think as a builder, you can absolutely participate in, right? So that's a few examples of things that we can build. There's lots of other things that I think are important. So public goods funding is important, and I think there's a lot of good ideas around making better quadratic funding applications, better ways to do credit assignments to figure out exactly all of the different participants that are responsible for making some public good happen. So not just the person who claims credit at the end, but kind of the entire tree that led up to them. There are better ways to do governance for DAOs, also important. Better kind of meta applications, applications that other applications can talk to, right? So I think there's this big long list of things that are worth making, but I also think that another thing that's important to realize here, right, is that like the technology is making it easier to build these things in a way that was not true 2 years ago, right? Like 2 years ago, we did not have scalability, and you could not practically do any of this. 2 years ago, zero knowledge proof technology was just not as good. It was much more difficult to use. And so 2 years ago, it was just much more difficult to build anything privacy preserving. 2 years ago, we did not have like many parts of this stack. And when you only have like one part of the stack, it's very difficult to do other things. But when you have like some version of all parts of the stack, then it becomes much easier to build even better versions of any part of the stack, right? So technology is improving, and I think it's possible for any of you to help participate in making this effort of making the technology better and more secure and more reliable, cheaper, and more accessible. But also really start thinking about, well, what kinds of new applications will all of this and new technology make possible?